Hello everybody! In this video, I would like to talk about the various arrows that are used in organic chemistry. When you start studying the subject, you're going to realize that different arrows are used to represent different things, and they fall into two general categories, the curved arrows and the straight arrows. So let's talk about what they mean and how they're used. Let's start by looking at curved arrows. Curved arrows represent the movement of the electrons, not the nuclei, only the electrons. And they always have a head and a tail. The tail starts at the electron's current position, and the head points to where the electrons are going. And this could either be within one molecule, or it could be from one atom or molecule to another. Let's take a look at an example of an acetate ion. And we're going to derive its resonance structure using curved arrows. To do that, we're going to take this lone pair on this oxygen and move it over to make the double bond. And simultaneously, we have to take a pair of electrons from this double bond and move it over to become a lone pair on this oxygen. When we do that, we get the resonance form. In another example of nucleophilic addition to a ketone, we can use a curved arrow to move the electron pair from the nucleophile over to the electrophilic carbon here. And at the same time, we use a curved arrow to move the pair of electrons from the double bond to make a lone pair on the oxygen, to get the following product. Notice that in both of these examples, a pair of electrons was being moved over at once, and this information is contained in the shape of the arrowhead, meaning that when a pair of electrons is being moved over, then the head of the arrow has a pointy thing from both sides. But what if we had a situation where only one of the electrons was being moved? Well, to represent that, we use the half-headed arrows that look like this. We can use the bromine molecule as an example. When this molecule is exposed to light or heat, the bond between the two bromines breaks and we make a pair of bromine radicals. And to show that, we draw a curved half-headed arrow pointing at one bromine and a curved half-headed arrow pointing at the other bromine. And what this tells us is that one of the electrons from the bond went to one bromine and one electron from the bond went to the other bromine. Now let's talk about straight arrows. Some of them are used to represent conversions, and another is used to show resonance. Let's start with the forward-facing, single-headed straight arrow. This kind of an arrow is used to represent the reaction proceeding forward from the reactants to products. For example, if we have methane reacting with oxygen, we could use this kind of an arrow to show that the products of this reaction are going to be carbon dioxide and water. Next, we'll look at the straight double-headed arrow. This arrow is used when showing different resonance structures. So in our acetate example, we actually should have been using this double-headed arrow in between these two forms. And what this tells us is that the real-world structure is a hybrid of these two resonance structures. And it does not tell us that these two are interconverting into one another. Also note that when the double-headed arrow is used, all the nuclei remain in the same place, only the electrons are drawn in different places. Lastly, let's take a look at the straight stacked arrows. These arrows are used to represent equilibrium between molecular structures that can convert into one another. Keto-enol tautomerism is a great example of this. Notice that both of these structures have the same molecular formula, but their atomic connectivity is different. Under most circumstances, these two spectroscopically identifiable structures will be coexisting in your sample and interconverting into one another, and we say that they are in equilibrium with each other, and indicate this with the stacked straight arrows pointing toward each of the molecules. Certain factors such as temperature can influence the equilibrium. So, for example, if the equilibrium lies toward the keto form and we have more of it in our sample, then we draw a bigger arrow pointing toward the keto form, and a smaller arrow pointing toward the enol form. This sums up our lesson about arrows, so make sure that you're using arrows correctly in organic chemistry. I hope this video was helpful for you. Please let me know what you think and what other topics you'd like for me to cover, and I will see you next time.